Alright, I think we're ready to begin. No, it's kind of delayed. I don't like that. Oh well. Okay. How delayed is it? It is... Whoa. Okay. Well, let's begin anyway. So I guess we should go over some announcements. Whoops. Let me see if I can close this. Okay. Slight technical glitch with the pad. Maybe I don't need it. If I can't figure it out in the next 10 seconds, I'll just ditch it. Yeah, it's going on the wrong monitor. Okay, I'll just ditch it. Alright. So let's do the announcements with Notepad, I guess. That's fine, right? Okay, Notepad it is. So, announcements. Yeah, sorry about that. My tablet is drawing on the wrong screen, so never mind that. Alright, so what are the real announcements? So the announcements are that exam 1 is being graded. Homework 5 is out. Lab 6 is out, or is going to be given out in discussion. What else? For anyone who's wondering about Lab 1 redo, I am going to grade that personally. And I'm going to try a new experiment. So that's why there's been a delay. But basically, if you're doing the lab redo, then, you know, you'll probably get the points for it. I'm just writing something that will hopefully kind of automate some certain things for me. But I haven't had time to really get around to that. So... and I guess Project 1 is going to come out maybe this Friday. And so Project 1 is going to, I guess it's not too presumptuous to say that it's going to be a version of Monopoly, the game. You know. So, that's basically all I have. Let's see, what else? I guess this is just another reminder. I'm sure that, are we going to have Project 1 and Homework 6? No. So while Project 1 is going on, there are no homeworks overlapping with projects. And projects are 2 week. Basically, pretend that projects are one problem, but 2 weeks to do it. And it's kind of like homework. Alright, so that's kind of the idea of projects, is that you're going to do a project, and then you'll do homework 6, then homework 6, then Proj 2, then Proj 3. And so keep in mind that there are no... after homework 6, there's no more homeworks, and are projects all done in one file? The answer is it depends. I think for Project 1, all one file. Maybe for Project 2 and Project 3, we'll have modules by then. Yeah, so basically, the academic integrity quiz. You know, I put it on the bottom of the syllabus, and basically, we normally give it out around the time Project 1 comes out. I might be lazy and release it maybe like next Monday or something. Don't worry about that, right? Like, of all the things to worry about, you should not be worried about that. What else is there to say about this class? Yeah, so everything has been graded. Will you have labs? Yes, labs, you know, are eternal, right? There are always labs. The one thing to say is that towards the end of the class, so we're kind of accelerating the lab schedule just a little bit over the regular semester, so it might be that we're able to do some more interesting labs towards the end of the semester that involve things like Flask or, you know, other things that are kind of like applications of Python that normally we don't get to do in this class, but there's some time at the end of the semester to do some like interesting things, I think. So hopefully we can do some of that. Okay, and then what else should I say? So our project's individual, yes. Unfortunately, everything in this class is, you know, everything in this class is an individual effort. Which brings up the unfortunate business that I was dealing with recently. I was just looking around, and I mean, I'm going to say there's not a huge amount of it, but there's a lot of, well, I don't know. Is it a lot or is it a little? Who cares? Is there an easy way to convert your Python code into a Flask application? Yeah, I guess, right? When exam 2 rolls around, we'll have a project at the same time. I'll have to check the calendar. I might... We'll see. Okay. So, anyway, the thing I want to talk about is, unfortunately, I want to talk a little bit about academic integrity. I've been scanning for it, and I mean, so what I'll say is that the same crap that has been going on in every previous semester is also going on this semester. I don't know yet whether it's more or less. Unfortunately, it's stuff that I'm going to have to deal with. Just because you haven't received an email about it doesn't mean I haven't found it. And by it, I mean mostly it's Chegg Solutions, but other websites and random other things that are, you know, that are way too suspicious. I'll use the modern term, sus, to ignore. So, you know, none of this makes me happy, right? So, like, last night I was kind of despairing, and I was wondering if it was all worth it, and I shouldn't just... I don't know what. I don't know what the right solution is for this kind of stuff. You know, I beg people not to do it, and they do it anyway. So, I'll just have to figure out. I guess we'll just have to do it again. So, yeah, so this is, as I say, this is always like my definitely least favorite part of my job. And by least favorite, I mean most hated. I really hate it. So, anyway. Yeah, you know, anyway. So, okay. Now that I am going to... I don't really want to talk too much more about this stuff until, well, ever, really. Anyway, so this is just yet another plea. You know, if you're having trouble, get help from all the TAs, right? Don't go on Chegg. Because Chegg means you're going to get an F in the course, probably, if you cheat on more than one thing. You'll at least get a 0 on the assignment or an F, I guess, is really. And if you get help from, TAs, you might get the B. Or the A, even, right? And that means you pass, right? So one way, you have a chance of passing. The other way, it's less good, so don't do that. Okay. What if a TA doesn't help you that good? Well, so, TAs have a hard job, right? They're not there to solve, there's always that last gap of reasoning that you gotta do yourself. And unfortunately, there's not, always an easy way to get someone to realize it, or to get them over the hump from here to here, even though it's the TAs take the distance of the jump from, this wide to this wide, but you still have to make the jump. And so that's the thing. The TAs still have to, you still have to make that last jump from a bunch of hints to the answer. Alright, so now that I've said all this about academic integrity, which I feel like I sort of have to say it, just because I'm seeing it pop up more and more, and I know exam 1 was hard, but I would have, so here's the way I really look at it. So if you want to know the secret is, if the exam average was just bad, then there, might be a curve. But if there's a ton of cheating on it, then no curve and just zeros. So I don't like that. I'd rather, if I write an exam that's legitimately just too hard for everyone, and everyone is failing it, and no one passes a single question, that's my fault. That's on me. Can you get help on the projects? Yes, on projects, tons of help. Okay? Do I know that I can notify Chegg? Yes, I've talked to Chegg before. Chegg is, believe me, Chegg is not entirely helpful on that regard, okay? Chegg knows what its business model is. Okay, so, I've tried to tell Chegg before that, so actually, I think, I'm going to say that Project 1 is, I'm going to try to make it easier than Homework 5, but maybe longer. Right, so it's longer than any individual problem, because when I write up the solutions for a usual homework problem, if you look at, for instance, okay, I guess I shouldn't show any test solutions. Maybe I'll show a solution to, maybe Homework 4? I don't know. Let's look at Homework 4 and see what a solution is. This is a stupid solution. So, this is my solution, for instance, to the encryption problem, for instance. And you see that here, this is just a bunch of printing and inputting. The real code here, it goes between lines 6 and 12. So I'd say that this is about maybe a 6 to 10 line solution overall, with a bunch of prints and inputs around it. Right, so when I write up a solution to any particular thing, yeah, I guess I can zoom in, if you really want that. My point is not the size of the, right, the point is not the, it'll matter in just a second. So, but okay, so, will there be a model for the project like the starters? Anyway, so the point is that, these are the solutions that I write. So basically the way to think about the homeworks is that there's always some solution that uses legitimate code that is within about 10 lines where you start the real code. I'm not talking about inputs and prints and if name equals main stuff. I'm saying for the real, honest to God, the algorithmic part of the code, usually less than 10 lines. And the reason why I say that is because I think some people some people end up thinking like, oh, there's no way to come up with a solution, and you get really complicated solutions and like 80-line stuff. But well, I'm not saying it to make you feel dumb. Like when I wrote Python the first time, and I would say a decent programmer at that point. Like my Python solutions were like 4, 5, 6 times the length that they should have been. I was doing all kinds of stuff I shouldn't have been doing. But as you learn the language, you'll be like, oh, there is a shorter solution. There is a more efficient solution. And so that's kind of where I'm going with this. It's just that it's not that you have to find the shortest solution. It's just that if your solution's 80 lines, then you might consider rethinking the problem and trying to, yeah. Well, so I was thinking about it, and I was thinking like I didn't want to post solutions because then I can't use the problems again. But they're all on Chegg, so I might. And also the solutions on Chegg are weird on Chegg. So, at what level in CMSC do you get graded on the efficiency of your program? That would be 341. Let's see. Constants are a part of coding standards. Yes. Can you post all the homework once it's graded? I might start doing that, at least for a few homeworks back. What else? Why are points off for not having a global variable? I'm not sure. Are sites like Stack Overflow fine? I guess the question about Stack Overflow, the answer about Stack Overflow is like, Stack Overflow is okay as long as you're not asking the question, okay? Or as long as it's not the exact question from class someone else posted. So Stack Overflow tries to basically eliminate homework questions for a lot of reasons, but yeah. They don't prevent all of that, so yeah, we're just gonna have to accept that. Alright, so I think that's it. I want to talk actually about course material today, so let's do some course material. Okay, so now that I've wasted a huge amount of time, but I think it was, I say wasted, but I think it was actually a good amount of time to just go over all the administrative stuff from the class. I might even kind of rewrite this and post this as some kind of like thing, either in announcements or something. Anyway, yeah, I was thinking about posting homework answers. I know the TAs kind of want to post all their solutions. Everybody wants to post their solutions, and I've been kind of holding everything back just because... the thing is, like, I still have this crazy-eyed notion that it's kind of hard to come up with all these problems every semester, so I really wanted to just, like, not have to reinvent every single problem every single semester. But I've been doing that anyway, so I guess I'm just not really very smart. Okay. All right. So let's talk about slices. So what are slices? So let's say that you have a list. Sure. Cool. And so a slice is basically a sublist. Okay. So what does that mean? What that means is if we say B list is equal to A list, and then here's the notation for it. So the notation is start, colon, stop. And you do all of that inside of a single array index. So notice that if you wanted to access, for instance, the element at 3, you would say print A list at 3, and you would get 4, right? But if you say you want the elements from, say, 3 to 7, and let's see what that does. So now let's print out blist. Okay? So let's see what happens here. Cool. Might be a little hard to read that. Let me see if I can increase the font size of the... I know I can, I just... let's see, console font. Let's make that 24 as well. Okay, there we go. So, would you say the Crash Course book is going to be more useful as a supplement now that we've gone over functions? Well, so, I mean, if you're saying that the book is a reference, sure. The percentage of the people that drop this major after 341, very low, actually. So 341, by the time you get past 201 and 202, your percentage of passing 341, at least within your 2 tries, is fairly high. It's like 95%. So 201 is really hard, 202 is really hard. 341 is also hard. I'm not going to say it's easy, but normally by the time you get to 341, you've already had a lot of practice doing kind of things that are required in that class, at least in terms of the coding aspect, and then there's the math aspect. So data structures is like the merger between mathematics and programming. Yeah, so this class has a much higher what we call DFW rate than that. Anyway, so let's go back to talking about this. So look at this thing. So we go from 3 to 7, and now let's actually see what happened, right? So we start and we go, this is 0, 1, 2, 3. So actually, let's just put a comment here. 0, 1, 2, 3. Okay, so 3 is the first index. And then here's the 4th index. So we're saying go from 3 to 7. So 3, 4, 5, 6, 7, 8, and finally 9. Okay, cool. So these are the indices, right, for these elements. Now, if you look at the indices for these elements, we're going to see something that's interesting. Well, A, they're all shifted by 1, but ignore that fact, right? The real interesting fact is that it starts at 3, and it goes up to 7, but does it include 7? And the answer is no. So it's exclusive of that endpoint. It's inclusive of this endpoint. So basically, this is like... in mathematics, I guess, it'd be like a half-open interval. So it's like 3 to 7 with a parenthesis, right? But, also I'll put that in scare quotes, like. Yeah, it's a lot like, it's way more like range. Yes. And the reason why this thing behaves like it does is because range behaves the same way it does. It's just making everything consistent in Python. So let's do another slice. Let's say we have CList is equal to A, B, C, D, E, F, G, H, I. Okay, so now what I'm going to do is I'm going to do something tricky. I'm going to say, let's start at CList 0 and go up to, say, 5. And so if I print this out, we're going to get something. A list of range... No, so that, unfortunately, that won't work. You'd like that to work, right? But that is going to result in some kind of explosion. Yeah, type error. But this is basically like the range operator for a list. So, yes. So what happens in this case, right? So here we go 0, 1, 2, 3, 4, and then here's the 5th element, but remember we don't take the 5th element, we exclude it. So then this list will be that. This lets us get around making it back into a string and back into a list. Sometimes, yes. Is there a way to do inclusive, exclusive? Not really. The notation is kind of fixed, right? So it's always inclusive of the first endpoint, and it's always exclusive of the last endpoint. And yes, the 5th element is a great movie. So you can slice things other than lists too, but before I get to that, let me show you an equivalent notation for this, which might be a little confusing. So sometimes a true tricky Pythonista will, Pythoner or whatever you call them, can you only slice with an index? I think the answer to that is yes. How did you do union signs, like with the interval notation? Can you do unions? Not quite. So if you look at this and it doesn't have a first endpoint, the secret is that if you omit the endpoint, it'll give you 0 by default. So these two things should print out the same. Hopefully they do, otherwise I've lied. And they do. All right. And now we're going to print a D-list, and of course the D-list is going to go from, say, 5 to the length of, 5 to length of, say, C-list. Oh, wait. There we go. And so this is going to take a slice. Yeah, so if you want to do a union, you'd have to just add two lists together. So I'll show you what I mean by that in just a second. But right now we're just kind of taking slices. So here what I'm going to do is I'll print this out. So let's track and see what this does, right? So 0, 1, 2, 3, 4, 5. So it starts on 5. And it goes 6, 7, 8... And right, how long is this list? 1, 2, 3, 4, 5, 6, 7, 8. Whoops. Did I take the I out somewhere? Yes, I did. I moved the I by dragging. What would happen if you did CList 5, 0? Good question. So, this is a good question. But before I get to it, let me just show you the trick here. You can also just leave this thing blank. So be careful with this one. It's not indexing, it's slicing. Ugh. So this will generate the same, these two will generate the same thing, and these two will generate the same thing. And of course here, we see what the answer is. When you go 5, 0, what's the problem with 5, 0? Right, it's like going, for I in range 5, 0 without a step argument. It's like this. And so I'm going to print out the i's that will happen. And what you're going to see is that actually this thing doesn't evaluate. And the reason why is because it starts at 5. Remember what the default step is equal to 1. So that's a positive 1. So it's going to go up from 5. So either, right, this is an infinite loop, or not, right? And if not, it shouldn't do anything. And so let's see what happens. See, nothing printed here. So why did nothing print here? And the reason is that because range is kind of its own function, what it does is range is a weird object. It returns something called an iterable. But if you don't want to worry about all that, then all you have to really think about is that range calculates, right? It calculates, basically it does this calculation. It says if end minus start is basically the same sign as the step. So if end minus start is bigger than 0 and step is bigger than 0, then, then we go. Else, if, end minus start is negative and step is negative, then we go. Else, we don't go. Right? So that's the thing here. If the end minus the start is bigger than 0 and the step is bigger than 0, then we go. If the end minus start is less than 0 and step is less than 0, then we go. And if else, because what happens is it says, oh, I need to go from 5 down to 0 in steps of +1, you would say, don't do that. if you ever said, I need to go from -5 up to, or if I need to go from 0 up to 5 in step size of, say, -1, also bad, right? And it's the exact same thing for step. It's the exact same thing for step. I'm sorry, slice. So slices, this will produce an empty slice for the same reasons as below, right? Basically, you're saying start at 5, go up to 0. But that doesn't make sense. You would be going down to 0. So that's why you don't do that. Okay. So, what else should I talk about with slices? Let's move on. So let's do another example. So the next example is a string slice. So let me show you that. So if a string is equal to, let's make sure that the string doesn't have any spaces. Is there a similar step? Yes. So I'm going to make this kind of a C++y, camel-y type case thing. The reason why I'm doing that is so that we don't have any spaces, just so that you can obviously see what's going on. So I'm going to print maybe a string from, say, 6 until the end, and let's see what we get. So hopefully what we get is 0, 1, 2, 3, 4, 5. Hopefully starts on this, unless I miscounted, right? And then it hopefully goes to the end, unless I don't understand. So 0, 1, 2, 3, 4, 5. A should be the first one, and it should go to the end. Let's see if that works. Cool. I didn't miscount. Let's do another one. Let's print, say, a string from, say, 3, which I've typed in as 2, so we'll go with it, 2 up to 12. Now, what does this do? So let's print it and see. So this is 2 here. And so this will be 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the question is, does it take R? Yeah, it's going to take R. But does it take I if I is at the 12th position? So it probably takes R. Does it take I? Good question. So you don't need to turn the string into a list to slice it. No. So strings and lists both have the slice feature, which is just beautiful. So, okay. So let's print this. There we go. All right, cool. So it started where I thought, and you notice that it takes R. Does it take I? No, it doesn't. Right? No, it doesn't. Okay. I need a sip. So that's the right answer, or that's the right question. So the next right question is, what does this do? Let's see what it does. I think, so here's something that slices do for you that, let's see. It might produce an index error, or it might do nothing. Because sometimes slices do nothing and just give empty strings. So let's make the end line equal to, this is the end, that new line. So, okay, well that didn't help. Let's print out hello here, just so that it, or about to test. And now let's do this, right? So about to test, low I am a string, this is the end. So you see that this is the string test. So what did this do? Right? It didn't give an empty string, and it didn't give an index error. It corrected itself. Right? So what do you think about that? That's kind of weird, right? So the only problem with slices is it actually kind of disobeys the general kind of poem that governs Python. So let me see if I can pull up maybe PEP 20. I think it's PEP 20, the Zen of Python. So here in this poem, it says, in the face of ambiguity, refuse the temptation to guess. Well, the slice is guess, so that's bad. Right? Let's see, where is it? It should say, errors should never pass silently. Well, claiming an index that's not in range should have been an index error, but slices don't do that all the time. They're generally more forgiving. So you see that here, this is also not followed. So we should write a letter and complain to Guido, or Guido von Rossum, or whatever his name is, however you pronounce his name. I don't know that I've ever actually heard it pronounced. Anyway. Yeah, it should have been an out-of-bounds error, but what it does is it just goes to the end of the string, and then it stops, right? So it goes to the end and stops. So that, in a way, it's good. So it's good because it doesn't error, and it's bad because maybe now you think this, think the string has length whatever, which is bigger than the actual length, right? So, it's a problem. Yeah, I'll write a strongly worded letter. Okay. So anyway, let's slice a few more things. So let's say print a string, and then let's slice it from, I don't know. What should we slice it from? So we should slice it from, say, 3 to, or let's say the first thing all the way to, and what's the length of it? Oh, here's a good, what does this do? Yeah, this is a good trick question, or it's a tricky question. So what this does is it's going to, what this is going to do is it's going to set the defaults. So it's going to set the first default to 0, and the second default to length of a string. So it's actually just going to print out the everything. Yeah, it's kind of weird, right? This is going to print out everything. So as it turns out, this is a tricky way. So basically, if you ever want to copy an object, right? So sometimes you might need to make a copy of a string. So if you ever want to do that, you can say, B string is equal to A string like this. And actually, this is another way to copy strings. It's also another way to copy lists. And so, for instance, if you have, say, a list is, or let's say copy list is equal to a list like this, you'll sometimes see this in Python code. In my opinion, I'd prefer other copy list equals list of a list, right? I'd prefer this because is there a benefit? So, right. So that has to do with mutability. So is there a benefit to doing it this way rather than just saying copy list is equal to a list? So remember what happens with mutability. Let's say ref list. We'll call this ref list. So let's print out a list. And now what I'm going to do is I'm going to go ref list 4 is equal to 21,500. And then I'm going to print out a list again. Okay? And do we copy things often in Python? You copy things often in a lot of programming languages. So if you remember when I was talking about mutability, so B string is equal to A string, So A string and B string are immutable, so this might not be necessary. This may not be necessary, but because of immutability. Like, technically you can't change strings anyway, so this might actually be kind of irrelevant. But this is definitely relevant, because watch what's about to happen. We printed a list, right? We printed a list. Well, these are the important lines of code here. So we set ref list is equal to a list. And so by ref, I actually mean a reference. And now what is a reference? So remember what a reference is. A reference is kind of the idea that you have the same list object sitting in memory, and you have two names now that point to the same object. So for instance, a list is a variable name that points to this list in memory. But also ref list now, because I've set ref list equal to a list, it also points to the same place in memory. And so the thing is, when I print out a list, it prints out the thing that it's looking at, which is this list here. And then because lists are mutable, you can change them. But remember that both of these things point to the same object. Yeah, it's kind of like a pointer. I know I'm saying points. It is a pointer in a way. Yes, it assigns another reference to the same object in memory. And so that's a problem, right? Because, yeah, if you print out ref list, that will also be changed. Like that. But if you print out, for instance, say, copy list, right? If you remember, hey, wait, copy list was all the way back up here, or for instance, other copy list, right? Now, a list and ref list point to the same list, but here we made true, what are called deep copies of the list. Okay? You do a true deep copy, and what a deep copy means is that you don't just copy the reference to the object, you actually copy the entire object, you make a new one with all the individual elements copied. So that's what you do. So the point here is that if I run this, what we should see is that the original, or I shouldn't say the original list gets modified because ref list is pointing to the same list as a list, but the copy list and the other copy list will not be modified. And the reason why is because you see that we used a different notation here. Instead of just setting it equal, we did the total slice, or we did this, what we might call like a list constructor here. You might call that a list constructor or something. So if you do, then that's fine, and that's what I would call it. So when I hit this thing, you're going to see that these two are completely unaffected, and it's because they have been truly deep copied, right? They are different elements in memory than the original A list. And so, yeah, it's always good to talk about mutability again. Okay, what else should I say about slices? Well, so now that the lab is turned in, let's do the lab again, but with slices, so that people, I know some people tried to do it with slices, but whatever. So remember that the lab from last week, right, was check how many rotations there are of a particular string. And so what we do is, let's look at input, enter string, and the string equals this. So, yeah, so here's the way that we kind of intended you to do it. So we say for offset in range 1 to len of the string, and then we intended you to do something like, I guess, new string is equal to empty string for I in range len the string, and then what we can do is we can say new string plus equals the string at I plus offset mod len of the string. Okay, So that was what was intended, and then basically here what you're going to do is you're going to say if new string equals the string, then we print, what do we print? The offset works as an invariant rotation or whatever. And yes, so this is one way to do it. So if we do, like, for instance, let's enter a string ABC, 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 and what we're going to get hopefully is the right answer unless I screwed something up. So you see that the offset 3 works, the offset 6 works, and the offset 9 works. So this is the original intention of the code. I don't want to talk about negative slices right now just because I think if I talk about it all at once, I might do that tomorrow. By tomorrow, I mean Wednesday. So let's rewrite this code to use slices. I mean, so this is kind of, so I mean, negative slices will work. I just don't want to talk about them because I think that, I mean, this is fine, right? I'm pretty lazy, right? This is fine, right? I think this is okay. Meh. So, okay. Let's do it again, okay? Let's do it again. So this time we're going to use slices. So I'm going to say for offset, negative, that did not work. Try again. Cool. So now what we're going to do is, now we have to think really, really, really hard for just a second, right? So, and of course that's always really, really hard. Yeah, so let's think, think mega hard right now. Yeah, let's do it. So basically, in order to do this, the offset is where we start in the string, right? The offset is where we start. So I want to make a new string, which is equal to, say, the string from the offset all the way to the end, right? And so what is this going to give us when we do this? Let me just print this out and show you what this does, and then we'll think about it a little bit more, okay? So let's do A, B, C, D, A, B, C, D, A, B, sure, C, D. And so let's enter the string again, A, B, C, D, A, B, C, D, A, B, C, D. Blech. So you see what happens, right? What it does is when the offset is 1, it'll strip off the first letter. When the offset is 2, it strips off the first 2 letters. When the offset is 3, it strips off the first 3 letters, etc., 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 all the way down to nothing. Okay, so if it does that, then we need to add those letters onto the end, right? So how do we do that, right? So we need to take the first offset number of letters, right? So however many letters that is the number of letters is offset. So we need, and then we need to take offset number of, let's just say number offset of letters and smash it onto the end. So let's see what happens if we do that. So this is going to be the string from 0, technically, I'll write the 0 in, up to offset. Alright? Yeah, basically. I'm putting the 0 in here, you can admit that. Personally, let me just say for a second that I actually do like it when programmers are nice enough to put this little 0 in here. Let me promise you that when you're actually looking through code, it's very easy to miss that this is a slice, and you think it's just an array index, and then you get mega confused when it's not doing the thing you expect. So it's a nice feature when the programmer will throw in a nice little something here and not just leave it as default. But, you know, everybody is their own human being, and most people are wrong. So if new string equals the string, then we print Actually, we could just copy paste that line. So here we're doing it. This is basically, what is this doing? This is doing the inner for loop. So enter a string. Let's do ABC, 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 ABC. Cool. Enter. So 3, 6, 9, 12 works as an invariant rotation or whatever. And there we go. So this does the same thing. So you see that these two pieces of code should produce the same output. Let's check to see if we enter in hello there. That should produce no invariant rotations. Good. Right, so we see that this is basically doing the same thing. So this loop here, which is taking new string and adding on the character at I plus offset mod the string length. And why does this work in the same way? Because here what it's doing is it's taking, you start at offset, right? Let's actually think of it as offset plus I, right? It's going at offset plus I. So that's this part here. It's starting at offset and it's going till the end of the list, right? It's adding on to I until we get to the end of the list. And then once we get to the end of the list, then this modulus operator is going to wrap us around, right? So like for instance here, let's just output some stuff. So for I in range, say 25, if we print out like I mod 5, then what we should see, let's say end equals space, something like that, just to make it clear. So let's hit go on this. So ASDF should have, well, let's just do something. So cool. And then you see here how this thing works, right? So for I in range 25, what that's going to do for us is it's going to go from 0 to 24. It is almost like, yes, that is exactly like the eightfold path thing. So basically here, what it's doing for us, it's going 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, 0, blah, 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 right? So that's what this mod 5 is really doing for us. It's giving us the wraparound effect. So whenever we get to the end, it's basically shoving us back to the start and allowing us to go through the list again. So that's really kind of the idea here. So, okay, what else do I want to show about slices that are good? I think I've showed a lot of stuff about slices that I want to show today. Let me think. So there's a homework problem, right? There's a homework problem. Genetic extraction. So this problem, it doesn't, so I'm going to say this, it doesn't require slices. But, if you remember what the starting position is in your string, so here's the two hints that I gave. Consider using a list to track the start codon positions, and you're encouraged and permitted to use slices. Basically, if you use slices, what is it going to do for you? It's going to remove a loop, right? So you can do all of this with an extra for loop. There's nothing wrong with that. The only thing wrong with that is that you can use slices. So I would say do that. Right? I mean, I'm not saying you have to. If you really can't figure it out with slices, then just use for loops. We're not gonna require you to use slices, but you're permitted and encouraged to use them if you can figure it out. And the reason why I'm gonna stop and not teach anything more about slices today is what? And so you might ask, well, why don't I teach negative indices and the step argument and all other kinds of crazy slice things you can do, right? You may think, why don't I do that? And the answer is nothing more than what is here is required to do the homework. Homework 5, part 1. I mean, the internal function part can be about, I'd say 10 to 15 lines. I mean, if it's absolutely minimized, right? You can minimize it probably to about 10 lines. But it doesn't have to be minimized. It just has to work. Anyway, so that's why I'm stopping right here On Wednesday, I'm going to go into more advanced Slice features, and we'll talk about things that go beyond the homework, okay? But right now, like what I've taught you in Slices is all you need, right? Is all you need. So that's good, right? Okay. All right, so now I say we talk about, now it's time to talk about dictionaries. So let's talk about dictionaries. So I guess the question is, like, what is a dictionary? And the answer is, it's in Python, it's kind of like a list. But, and so how is it like a list? It's like a list in that it has the indexing operation, just like a list, except you can use anything immutable, meaning you can use bool, string, int, and float objects as what are called keys. So let me show you an example of a dictionary. So for instance, a dictionary here could be, let's just do a simple dictionary, my first dictionary. And so the syntax for it is this. The syntax is this, is that you use, like, a dictionary is equal to these, what are they called? The curly braces, and they go key, value, comma, key, value, comma, key, colon, value, comma, key, colon, value, etc. Right? And technically this is like key sub 1, value sub 1, key sub 2, value sub 2, key sub 3, value sub 3. The problem that requires it in this homework is part 4. Yes. So, for instance here, my first dictionary is going to be this. It's going to be hello is defined to be 3. Goodbye is defined to be 17. And revolution is defined to be 5. Flying, or let's say Dutchman is defined to be 3 again. So okay, first let's just print this thing out and see what happens. And then I'll show you how the indexing works. So let me just stick all this stuff into a function so that it doesn't execute. Let me go all the way to the top and just call it like def slice examples. Now that you know functions, basically you understand what this is doing. I'm just sticking everything in a function, and now you see that nothing is actually going to execute because I'm never going to call this function. You won't have projects and homeworks at the same time? That's correct. So if you print this thing out, it looks almost identical to the thing that we plugged in. Okay, so that's not telling us very much. But if we say print my dictionary, say revolution, and print my dictionary, say like this. Can you have a list of dictionaries? Yes. So here you see that if you access, and remember before, right, indices had to be integers. But here, they are clearly not integers. They are strings. And so that's okay for dictionaries. They can also be integers if you want them to be. So for instance, I could actually make, say, 1729 be defined as a key in here as well, and the key value could be, I don't know, 51. And so here we can look up print my first dictionary 1729. And good question. So here's an example which looks kind of like a list, but it's just because we're using int keys. The keys are the string in this case, right? Yes. So remember, the key is the first thing, the value is the second thing. So you have to pretend like this is a little function, and the function says f of hello is 3, f of goodbye is 17, f of revolution is 5, f of Dutchman is 3, and f of 1729 is 51. Okay? So, yes, so the keys are strings. If you, let's do the example. Let's do the example where we access a non-existent thing. The only difference between a dictionary and a list is that the indices in a dictionary can be called using a string. Yeah, more or less. More or less. So let's access my first dictionary at 3, as someone suggested to do, and so let's see what happens here. Boom. Now remember that errors, like the standard error stream, usually is slightly faster than the standard output stream. So really what happened was not, the error didn't happen here. The error actually happened right here. It's just that this output was kind of waiting in a buffer to get dumped to the screen. Could you use a dictionary to do the Caesar salad program? Maybe, if you're kind of creative. I would say you probably still need to use ASCII for it. Maybe is what I'll say. Maybe. Okay. Okay, so this... Yeah, I mean, you can do that. Sure. Anyway, so don't do this. Because it doesn't exist. So, what if you're not sure if something is in the dictionary? So, that's a good question. So, before you access something in the dictionary, you can always test. So, for instance, here, if we have some kind of dictionary, like, boom, 341, L, I shouldn't make it L, make it L, 211, Z, 5, red, 2, you know, whatever, and I guess a good number is 1618, right? Or, let's just make it, isn't 163 the number? I think it is. How do you add to a dictionary after it's already established? I'll show you that in just a second. So, alright. So, before you access something in a dictionary, you can always test. So, what if you want to know, right, print dictionary 3 wouldn't show an error? Yes, it would. Yes, it would. So, if, let's say, happy is in M dictionary, we print happy in there. Else, print happy not in there. So let's see what happens. So it tells us that happy is not in this dictionary. Okay? Yeah, so if you have that dictionary, then 3 would be in there. And so you have to remember that the dictionary is always looking for keys, not values. So let me show you what I mean by that. Can you have two different numbers? So let's just do that as an example. So double dictionary equals, yes, 5, yes, 31. And so if I print out double dictionary, what's going to happen is the second... so PyCharm is already yelling at me. It says contains duplicate keys. If I'm not mistaken, Python will actually allow this, and it will just overwrite this key with this key. So whatever happens second, I think, is what it takes. Let's see if I'm right about that. Yep, you see here, it overwrote the first key with the second key. So the moral of that story is that keys must be unique, right? You can't use the same key to open two different locks, right? And by open two different locks, I mean get two different data elements. I mean, so there's... Python doesn't forbid it, but you see it doesn't help you. Okay, how did I change my font size? I went Control-Alt-S in Windows, and then I found console font. You can search for console font. And you can also search for editor font. I changed them both to 24 to make it big. So, and then, so the don't do that is basically the rule there. Don't do that unless you absolutely, for some random reason, really want to. Okay, so the next question came up. So now we have a way to test if something is in the dictionary before we access it, so that's nice. Now we also have a way, so for instance, like, if I have a monster dictionary is equal to, you know, big, snake, crocodile, alligator, turtle. And of course we got to define values. What are the values? I don't know what the values are. The values of big snake are going to be 15. Value of crocodile is going to be 31. 182, and the value of turtle is 777. So, and monsters is not spelled with it, so monsters, there we go. So, we'll show you an example of two different things. So, what if we want to add a new monster? And the answer is what we're going to do is we're going to say monsters, and so watch this. We're going to say monsters, and then werewolf is equal to 31,768. And you might be thinking to yourself, like, why, you know, shouldn't this throw an error? And the answer is actually no, it won't. As long as the undefined thing is on the left side, right? So as long as it's being assigned, it won't throw an error, okay? So that's the thing to think about. So, so let's print out monsters. What if the keys are all different types and no error but to create traverse the dictionary? So, okay, so the first thing to say is that we see that monsters now has werewolf defined as 2 to the whatever power, and so werewolf got its way into the dictionary. So we can add monsters, Bigfoot is equal to 301, monsters, Yeti is equal to 302. And so, whoa, there we go. So now we're going to see all of these monsters be added to the dictionary. There we go. So, let me see here. So, you ask a good question. What if the keys are of different type? And the answer is generally avoid that, okay? So if you use integer keys, you'll use integer keys. If you use string keys, you use string keys. Could you do 4-key in monsters? Yes, you can. So the reason why you want to generally avoid that is because a lot of people are going to eventually, whatever dictionary you create, you're eventually going to go for name in monsters, print name. And so I'm going to show you what happens when we print all the names. So the names that get printed out are the key values, right? So these are the key values, okay? And so now if you want to know what are the actual values, then you need to go monsters of name, okay? So that's how, well, I guess not just go that, you print that. And actually, let's simplify the print statements so that we can say n equals, say, space, colon, space, just so that we have something in between everything. Let's do it. And so you see that Big Snake 15, right? Big Snake is the name, 15 is the value. With the colon here now, well, I guess we should actually make it a pipe so that it's not a colon and confusing with the actual colons of the dictionary. So this is just a pipe for output to keep them apart. Crocodile is the name, the value is 31. Alligator is the name, 182 is the value. The key is turtle, the value is 777. The key is werewolf, the value is 32768, etc., etc. Right, so basically, this is kind of what you have to do for that homework problem, because in that homework problem, it's actually like a dictionary of dictionaries, where each thing has an attack, which is say like 3, a life, which is 4, and like a first strike variable, which is say true, right? So that's what each one of these has. And so basically, this is what the dictionary is going to look like. Oh, why did you do that? Come on, don't do that. That's just mean. There we go. So there we go. And then finally, there we go. And then we have to add one more and brace. So now we can change all the values. So 5, 1, 17. The life of a turtle is 81. The life of an alligator is 40. Crocodile gets 39, and Big Snake gets 4. Okay. So, yeah, so basically that's right. Is it okay to have multiple keys with the same value? The answer is yes, because attack being 3 doesn't have anything to do with, say, life being 3, right? Like if you're playing Magic the Gathering, if you're playing a standard like RPG, it's okay if your strength stat is equal to your life stat, right? There's no rule that that can't be the case. So values are not checked against each other. But you see that in every one of these dictionaries, there can only be one attack, one life, one first strike. If you tried to define attack again, then it would overwrite the first one, and you wouldn't want that. So, okay. Turtle does be a little OP, but that's okay. Who cares? So, okay, let's do this. So you see that the output's kind of garbage now because it's like Big Snake is the name, and the actual value now is its own dictionary, right? And then actually, well, why don't we just make this new line? So there we go. Big Snake with this dictionary, crocodile with this dictionary, alligator with this dictionary, turtle with this dictionary, and of course we didn't actually do the right thing with werewolf, Bigfoot, and Big Food, and Yeti, so they just are still the numbers. Yeah, so if you wanted to change, say, the life, so say we wanted to do monsters, say Big Snake, and here you would go life equals 31, and then we could print that feature out. So this is a lot like 2D arrays, right? And so the answer to your question is yes, right? We can change the thing at Big Snake and at life, and then here it's the life of the Big Snake, and that's what it is. Okay. So I guess the last thing to talk about before we end for today is removal from dictionaries. And so what do I want to say about removal from dictionaries? What you basically have to do in order to remove something from dictionaries, so let's try to remove the flying attribute. And this is how you remove the flying attribute. So do dictionaries have a length function? They actually do. So if I print out, for instance, monsters and print out len of monsters, hopefully when we print out monsters, flying will be disappeared from the turtle thing. So let's check turtle and let's check that it doesn't have flying anymore. So you see here that turtle lost flying. And so now let's actually delete monsters wolf and maybe delete monsters big food, right? Because big food is not the right monster. But you also see here that it definitely prints out the length of it. So what is the length of it? Basically, length of a dictionary is equal to the number of keys in the dictionary, which is also equal to the number of values in the dictionary as well. But we don't have... So the thing is that, remember that in the dictionary, the keys are the important things. The keys are the way you access the values. You don't want to be thinking of it as something where you need the value to access the key. You want to always have the key to access the value. And the reason why you want that is because otherwise you might have to do a for loop through, say, monsters.values. And, like, this is print generally wrong, okay? If you're ever doing this, if you delete turtle, yes, it will delete turtle and it will delete all of its attributes. So for instance here, let's rerun this code. Let's ignore the generally wrong for a second. And notice that we deleted werewolf and big food. So you see here that, like, there's just no werewolf, no big food, nothing. There's nothing left in the dictionary. It's all gone. Couldn't you create a dictionary and then do a for loop that'll set their values? Generally, that's not how Python will allow you to do it. What you can do, on the other hand, is you can say for I in, or for, say, C in, like, A, B, C, D, you can say my new dictionary is equal to new dictionary, and then you can say my new dictionary at C is equal to ord of C squared plus ord of C plus 1, because that's what you are going to do. So let's see, right? And let's see what happens. Oh wait, now we have to print it. So you see that this here is kind of just adding up these numbers, and of course you might be like, what do the numbers mean? They are pretty random. Like, it's just kind of garbage for now. So don't worry about the numbers. I'm just making up an equation, so pretend like this is whatever, you know, you want the value to be. Which could be some equation, or it could not be an equation. It could be something, right? So if you actually tried to do this and were just like A, B, C, D, I think this might be legal because Python allows it. It looks like it might be legal. My guess is that A's value is going to be none. So let's see. My new dictionary equals that. Print my new dictionary. So it printed the dictionary, and then what did it do? Set object does not support item assignment. Oh. So if we look at the type of this thing, so I was wrong. This thing is not a dictionary anymore. So this thing is a set, not a dictionary. So you got to be careful. So don't do this because it's not actually a dictionary. It's a set, which we don't actually usually teach in this class, but yeah. A set is essentially, it literally just means like a mathematical set. So you can do things to sets like union, intersection, like all kinds of stuff. Union and intersection mostly is what you do to sets. What is a set? The answer is don't do this because it's a set and I don't want to teach sets. I want to teach dictionaries. So if you've seen mathematical sets, if you know what a set is in mathematics, then it's that. If you don't know what a set is in mathematics, then you have to wait until 203, and then you'll know what a set is, and then you can create sets again. Okay. I think, is that enough to get you guys going for the homework? But you can just Google it. Of course you can just Google it, yes. But the thing is that I have to kind of strategically choose what to teach and what not to teach, because if I teach too much stuff, then it'll overload everybody. And if I teach too little stuff, then people can't solve the problem. So I have to teach the right amount of stuff. I think that this has taught the right amount of dictionaries and the right amount of slicing in order to do the homework. And so the next class is going to be devoted to more advanced dictionaries, more advanced slices, that kind of stuff. But I shouldn't say more advanced. Just more examples, maybe that kind of stuff. So I think that's basically it. That's all I really want to say. The other thing I was thinking, and I don't know, yeah, you have to use del to delete objects. I think, is there, so there's a delete item, which is the thing that delete calls, so don't do that. It's best to call delete on something rather than, yeah. Let's see. So key A gives output 3 and takes the same output and reads key, gives Y. What is that? The output is A. There is no such thing as the third key. So remember, the one fundamental thing about dictionaries is that you cannot guarantee order to the keys. Okay, so the keys are allowed to come out of this. Technically, they're allowed to come out of this for loop in any order. So, well, I never said it was going to be extra credit. It just got buried under like my massive amount of work. As it turns out, you guys might have been working hard on this class, but I've definitely put in a lot of time into this class. So, I wrote up part of the survey. I just never sent it out. I think I'll have to do that. Anyway, so there's actually something called an ordered dictionary, which I think you can import it from there, but again, don't do that, because you don't need that for anything. So, you don't need that for anything. Okay, and then the last thing I wanted to say before we go offline for the day is I was thinking maybe if I'm going to release the solutions, maybe I'll do videos on the solutions themselves to explain them so that, like little 5 to 10 minute of each homework solution. And I'll probably, if I'm going to do that, it's going to have to be like, unfortunately, it's going to have to wait. It cannot be right at the due date of the homework, and the reason for that is because I give extensions, so I can't just do it right then. I have to wait a few days until all possible extensions are closed. Because if I do an explanation of the entire homework problem, then that would be probably too much. Okay. Yeah, it'd probably be like, it might be like a 1.5 to 2 weeks after. And it's just a fundamental problem of like extensions can go a little bit, and I don't want to screw up, people doing the work. So anyway, so that's my thinking. I was thinking I might actually do that, but I'm not sure. It'll take time, so we'll have to see if I do that. Okay, so that's all for the day. I think I will, talk to people on Wednesday. And I think that's it. So now I just have to find the thing to end the stream, and I have to find OBS to play the outro.